chlorine, bromine, iodine, and astatine. Let's start with fluorine. Fluorine, the name fluorine comes from the Latin fluere, that means to flow, because the most common fluoride mineral is fluoride. It melts when heated and it flows. Fluorine is a very reactive element. It is the most reactive non-metal, and it is found naturally only combined with other elements. So in the universe, we cannot find fluorine as a pure substance, but only combine it with other elements. Fluorine is an important element used, and it is used in our daily life in a substance called Teflon. This Teflon is a substance that is used in the pen. Look, do you see this dark layer on the pen? The substance, the name of the substance is Teflon. The second element, chlorine. From the ancient language of Greeks, chloros means yellow to green, or better say green color. And it is found dissolved in the sea as sodium chloride and in a rock salt. You know, the sodium chloride is our table salt. This gas, chlorine, fluorine, all halogens, in fact, are poisonous, are toxic gases. And chlorine was used in the First World War by Germans as a weapon. So chlorine is a dangerous and poisonous. The third one, bromine. From the Greek language, bromos meaning stench, and bromine is found mostly dissolved in the seawater like a salt. And just for to know, the purple used to stain the togas by the Roman emperors is made of bromine. This, what the emperors wore. The next element is iodine. From the Greek language, iodis means violet, purple, and it is found in seawater. Just for curiosity, silver iodide crystals can be used to cause rainfall. If water vapor condense around the crystals and become large enough to fall into the earth as rain. And the next element, the last one, is astatine. Astatine from the Greek language means unstable. Astatos means unstable. And it is not found naturally on the universe, but it is an artificial element. Halogens are non-metals and they are very reactive. But why they are called halogens? These elements are toxic and they are used as antiseptics. Iodine was used to clean wounds, and it is harmful to all things, including bacteria. These elements, halogens, are not found in the nature as a pure substances, but only combined with other elements. And the name halogen also comes from the ancient Greek language. Halo means salt, and gen means former or produce. So halogens, the word halogen means salt former. Okay, what these elements have in common? You probably have learned about electronic structure, simple electronic structure. Do you?
Yes,
Okay. What they have in common, all halogens, fluorine, chlorine, bromine, iodine, and aspartate, they have 7 electrons in their last shell, in their outer shell. The last shell is also called the valence shell. What does this mean? They can easily obtain an electron and to fill their outer shell with one electron. They will gain that electron, and all halogens will form negative ions with charge 1 minus. And what is the most important, they have similar chemical properties. This is in general about the halogens. Okay, since they need one electron to fill their valence shell or the last shell, so the halogens will combine with each other and will form molecules. For example, we have here fluorine. Each fluorine atom will give one electron and will form a covalent bond. So 2 fluorine atoms will form a molecule of fluorine, and this molecule is called diatomic molecule. Why diatomic? Because the molecule of fluorine and other halogens is made of 2 atoms. This is the reason why these molecules are called diatomic. All the halogens have diatomic molecules. Now let's continue with physical properties. All halogens are nonmetals. Therefore, they will not conduct electricity. They are brittle and crumbly when they are solid. The only solid, the only solids halogens are iodine and astatine, while fluorine and chlorine are gases, while bromine is a liquid, yes. All of them are poisonous and they have a bad smell. Now let's continue with the colors. Fluorine has a pale yellow color, the gas of fluorine. Chlorine has a green yellow color. Bromine is red to brown color, and iodine is blue black or purple violet, while astatine is gray, darker gray. Now let's continue with boiling points. So within the group, from top to bottom, the relative size of the halogens increases because the radius of the atoms increases. Another reason why the relative size increases is because the number of shells, electronic shells, increases. This is the reason why from top to bottom, the size of these elements increases. Is it clear?
yes,
Okay. Now melting points. Look, the melting point of fluorine is minus 220, chlorine 101, for bromine minus 7, and iodine 114. It means from top to bottom, their melting points, and on the right, on the column of boiling points, we can notice that also the boiling points increases from top to bottom. The melting point and boiling points increase because the intermolecular forces between the halogen's molecules increases. Have you learned about intermolecular forces, van der Waals forces?
Yes.
Oh, yes. So since the molar mass increases, the boiling and melting points increases. Fluorine, chlorine, bromine, iodine are nonpolar substances, and the only intermolecular force present between the halogens or nonpolar molecules are van der Waals forces. And van der Waals forces increases since the molar masses increases. Now the state. For state, we mean physical state. Fluorine, I told you before, fluorine is gas, chlorine gas, bromine liquid, iodine solid, and astatine is the solid. But remember, always at room temperature. At room temperature, these are the physical states, okay? So in this graph, we have another description of how melting points and boiling points change through halogens, always from top to bottom. Now, vapors. Halogens are volatile. What does it mean? They can easily turn from liquid into gas, but they also can turn very easily from solid to gas. This type of substances are called volatile. Vola, I don't know how much you know the Latin language, but vola means to fly. So since they can turn into a gaseous state, so it is used this word, volatile. Look, iodine very easily can turn from solid into gas, and this process is called sublimation. Can you answer these questions? It's just true or false? Do you hear me?
Yes, I do.
Can you answer this just to...
The first one is false.
Yes, false.
The second one is false.
The second one, the reactivity of halogens increases down to, yes, it is false. The
third one
one,
is true.
yes, it is. The fourth one,
The fourth one is false. The fourth one is false.
yes, it is false because we learned that there we have liquids like bromine and solids. Halogens become darker in color down the group from top to bottom.
False.
You think false?
Yes.
But they become darker. Actually, it is true because fluorine is pale yellow. Chlorine is green, brown, purple, and dark. Actually, it gets darker.
Okay, the
Halogens
fifth
have 6 electrons.
is false.
Yes, it is false. Okay, well done.
Thank you.
Okay, now reactions. The previous one was about physical properties, but now we have reactions. Reactions and reactivity. Halogens, we said, are non-metals, and they are relatively reactive. They react with metals, they react with hydrogen and produce specific chemical substances. Halogens have 6 electrons in their outer shell. So they will gain an electron to produce a full electronic shell. This means that halogens and metals react to form ionic compounds. Most of compounds between halogens and the metals are ionic compounds. Here we have 2 types of ionic compounds. The first one is nickel 2 chloride, and the second one is copper 2 chloride. The salts of halogens, the ionic compounds of halogens, are called halides, and these substances are metal halides. Okay, when the halogens react with another substances, they become negative ions. We said this, and they are transformed into ions called halides. It's okay. So how can we name the compounds of halogens? If the name of halogen is fluorine, the name of compounds of chlorine, the names of will be fluorides. For chlorine, chloride. For bromine, bromide. From iodine will be iodide. So we will change the suffix "-ine" with "-ide." Okay?
Yes.
Okay. Now let's watch an example how chlorine reacts with iron wool in this chemical reaction. The reaction is vigorous. The reaction is vigorous. It means it's relatively fast. Look, now with bromine, initially we have to heat bromine, then we have to heat the iron wool. This reaction, the second one, is slower. Are you there? Uh, are you there? It's okay. Did you hear what I said about the reaction between bromine and iron, or no?
No, please could you repeat it again? Something happened.
Yes. Okay. Let's start with chlorine. The reaction between chlorine and iron is fast. Look, the reaction is vigorous. This fume, this cloudy substance is iron chloride. Look, the reaction between iron and the bromine, it is slower. the reaction is slower, and the reaction between iron and iodine is even slower, is the slowest actually. Okay, I show to you these three examples to compare the reactivity between the halogens. Since the reaction of chlorine with iron is the fastest, it means chlorine is the most reactive, of course, between these two other elements. Chlorine the most reactive, then comes bromine, then iodine. Between these three elements, three halogens, the most reactive halogen is fluorine, then chlorine, bromine, iodine, and astatine. The reactivity decreases from top to bottom in the group of halogens. Okay?
Yes.
Uh, can we arrange this? Wait. Can we arrange? For example, chlorine. What is the right for chlorine? The first one, second one, or third one? We have to match with the correct
I
meaning.
think it's the second one. Yes, I think
Yes,
it's the
it's the
second
second
one.
one. Yes, yes. For bromine,
The first one
yes, the first one, and iodine
is the last one.
is the last one. Okay, well done. So this is the explanation I said before. Their activity decreases down the group. Okay, when halogens react with iron, they form iron halides. Halogen plus iron or any metal, any other metal, will give iron 3 halide. Why iron 3 halide? Because the valence of iron in this compound is 3.
Yes.
Here is the chemical equation. Any question? Do you have any questions? Sorry.
No, I don't.
Okay. So here are written the word equation and the chemical equation with chemical formulas. Look, chlorine reacts with iron and produce iron 3 chloride. 3 mole or 3 molecules of chlorine react with 2 mole of iron and produce 2 mole of iron 3 chloride. The chemical equation with bromine and also with other halogens is the same, since they have similar chemical properties. Okay, what is the reason why the reactivity of the halogens decreases down the group? Look, the atoms, the size of the atoms increases. So the radius increases. The distance between the nucleus and the electron of the last shell is higher. It means the outer shell gets further away from the nucleus and is shelled by more electron shells. The further, this is for nonmetals, the further the outer shell, and the lower will be the force of attraction between the nucleus and the lost electrons. This is the reason why the reactivity of halogens decreases going down the group. Halogens also react with nonmetals, for example, with hydrogen. Hydrogen is a nonmetal. And what will produce hydrogen halides. Look, this is how a covalent bond is formed between hydrogen and chlorine to produce hydrogen chloride. Hydrogen, 1 electron in the last shell. Chlorine needs 1 electron to fill the valence shell. And this is how the covalent bond is formed between hydrogen and chlorine. This is a covalent compound. Now with displacement reactions. A displacement reaction is a type of a chemical reaction in which the most active or the most reactive element displaces the less reactive. You probably have learned.
Yes.
So fluorine, yes, fluorine is the most reactive. We said about halogens. So fluorine, we displace all other halogens. So fluorine can displace chlorine, bromine, iodine from their aqueous solutions. This is the chemical reaction in general. While chlorine is less reactive than fluorine. Fluorine cannot displace fluorine, but chlorine can displace iodine, bromine, and astatine. Look how fluorine will displace chlorine from sodium chloride. Look, fluorine will gain the electron, will take the electron from chlorine, and will form sodium fluoride. Look,